Good afternoon, everyone. Today I want to present our source code for the advanced machine learning final project. So first we import the library. For import the required library, then we read the dataset. There is weather Australia.tcv, and then we check the missing value, whether the data is contain the missing value or not. And the result, there are so many missing value in the dataset. To solve it, we replace the missing value with the mean of data, and for the categorical value we fill it with the mode, but for the rain today and rain tomorrow, because there are a label attribute. So first we convert it, like if it's no, it will transform into 0. If it yes, it will be transformed into 1. And if there are still missing value, it will be filled by 0. Why we solve the missing value with replace or impute the missing value? In order to keep the element of data. And then we check again whether there are still a missing value. So its result on location attribute, there are one missing value, but we don't solve it because we drop the location attribute, since we don't use it like other attribute like date, when gas there, when there 9 a.m. when there 3 p.m. with the x is equal to 1. And then we convert the value into integer value. The previous value of the dataset is float, but we convert it into integer to make the process run more smoothly. And then we implement the T-pod tools for the automation of machine learning. We split the train and the test data, but we must define the x and y first. The x is all the attribute except the rain tomorrow, because it's the label that we use in this experiment, and the y is contain the label that we use, that is rain tomorrow. And then we convert it into x train, x test, y train, and y test. And then we split it, the x and y, with the train size is 0.8. But before we implement the T-pod, we need to install the library. That the command is pip install T-pod, and we implement the T-pod library. That from T-pod import T-pod classifier. We implement it with the generation is equal to 3, population size is equal to 20, and verbosity is equal to 2. We use the train data. There are x train and y train. The imitation progress is take a long time, but its result for the generation 1 is 0.87580, and the generation 3, the score is improved or increasing with the score 0.8764. On the generation 3, it's all increased too with the score 0.877. The best pipeline that produced by the T-pod classifier is gradient boosting classifier for this experiment. In order to know the T-pod score, we use the test data that already split it in the previous section. So it's produced 0.8913 and etc. And we can retrieve the result of the T-pod by using the command of tpod.export, and we name it with the result.python. I think that's all my presentation. Thank you for attention. Good afternoon.
All right, it's my turn to explain you the report. Thank you for my friend. Have you explained you the code? Now let's move to the report. See automation machine learning. Basically, the problem or from the data set they given in this final project is the daily weather observation from the multiple locations around Australia. This experiment will be solved by using Teapot automation tools from machine learning. I'll explain about Teapot later in the below, okay? Identify your data source. So the data set contains 10 years of weather observation in Australia. And automation machine learning will be using Teapot automation tools. And the data set has a target variable, which is rain tomorrow, that as a label of it. All features will be used this experiment except categorical features such as date, location, and the other because it's not affected. And then next, we'll talk about the exploration and data preprocessing. As I know, the data preprocessing is one of the most important steps because data preprocessing is a step that can do for identify the missing value, removal unwanted data, data cleaning, and then make the data more quality and more valuable. Okay. So first, in the data processing, we do here is we take the missing value, take the missing value in the data set, and then after we check, we find there is a couple of missing value here, as you can see, as my friend have shown you in the code too. And then we remove some of the unused data, and then has a lot of missing value. We remove it, and then we just replace some who which has just a little bit missing value. And then in the attribute rain today and rain tomorrow, the value will be converted into 0 and 1. The missing value will fill with 0 to make the value same with the converted values. So basically, we're just encoding the rain today and rain tomorrow because the data the the data of the rain today and rain tomorrow are categorical data types. So we just convert it into numerical. So and then we just replace the zero to those missing values. Okay, here is the code. And then the next step is to drop unused attribute. Okay, we just drop unused attribute, just I've explained. The attribute not used will be dropped. The process avoids error. Yeah, to avoid the error. Especially they are categorical data too. Drop attributes such as date, location, when this one, wind direction, 9 a.m. and so on. So we just drop. This is the code, and then we converted all the data into the integer value because the data set was the float value. So we converted into the integer values. This is the code. And then we train and split the data. The data contains all attribute except rain tomorrow attribute. For the training set, because the training set is not the rain tomorrow because the training rain tomorrow is using as a label for the test set. That's why we're splitting into training set and test set. Okay, this is the code. Here it is. And then for the modeling, we're using machine. In this automation machine learning, will be used Teapot as the data set, whether AOS CVS dataset. So we're using Teapot for modeling. And now I'm gonna explain you what is the Teapot. What Teapot is. Teapot is one such platform is available as a Python library. We can consider Teapot as our data set, the data scientist assistant. You know, Teapot is a Python programming. Teapot is a Python automated machine learning tools that optimize machine learning pipeline using genetic programming. It will automate the most the most part of machine learning by intelligently exploring thousands of possible pipelines to find the best of one of your data. So thank you Python for that to prepare this library. So by using this teapot, we can do our automation, okay? And then for the evaluation, we will evaluate the model using the teapot score that we got from the teapot classification, okay? From the training data, especially. Okay, now we move to the experiment. This is how we implement our process. First of all, we import the library. This is the library. I'm sure my friends have showed you in the code session. And check the missing value. If there is some missing value, it's important to make the data more valuable. Okay. After we check, we drop some unused and we replace some which is used. Okay. And then we split the data into training and test. Train data, training test, training set data is all except the range model, because the range model used for the test data because it is a label. And then the teapot classifier. The teapot classifier, we're using the Python library. For we're using the process, we use the generation score is 3, population score is 20, and velocity is 2. For those who want to know what is score is generation score is, where's my cheat set? Generation score is number of iteration to run pipeline optimization process. Okay, number of iteration to run pipeline optimization problem. And the other one is velocity equal to, which is mean state how this the velocity equal to state how much information to put communication while it is running. Okay, and then as we noted, running this code takes several hours to finish it. And after we finish, here is the result. As you can see, generation 1, generation 2, generation 3, because we're using 3 generation. For the teapot score will be used to test data and retrieve the teapot result. Okay, from those data, from those results, here is the conclusion. Based on the experiment evaluation that the teapot classifier produced 3 generations such as generation 1, this is the score, 0.87 something. Generation 2, this is the score. Generation 3, this is the score. In above 3 generations computed, computed, each given training efficiency with the fitting model on the training set. Okay. As the evidence, the best pipeline gradient boost classifier is also produced high teapot, which is have this with the score 0.89 using test set. Okay, here's the end. I'm sure there is a lot of work in here, and maybe you don't understand my explanation a little bit. So just thank you for your time. I hope you understand it.